Hello, everyone. Welcome to the Astro Imaging Channel. Tonight we have John as our presenter, and John's been on times before and always a very interesting presenter. But before we get to John, we have a little housekeeping to do. No show next week. The week after that, we have Richard Wright talking about chasing the sun, modular imaging. And then in June, we have Stocks and Nico Carver and Charles Brown on the Thuks in June. And then in July, there's a lot of open space on the calendar. So if you have a presentation that you would like to give, let me give presentation.
Really, the bar is pretty low. Go on over to the astroimagingchannel.org and send an email over, and Molly will get you hooked up on the schedule. With that, let me turn it over to John. Take it away.
Well, thank you, Linda. Let's see if we can, I'm going to share my screen here, and we'll see if we can do the entire screen here. Screen share, get that going, and we're going to try to get rid of, let's see if we can get
you should hit that hide button now so it doesn't pop you back over. Yeah, there. Okay. And also along the bottom where it says, yeah, there.
You found it.
Yeah, okay. And we'll bring this, oops, I'm sorry, press the wrong button. Bound to do that a couple times. Here we go. And we'll turn this, we'll make sure we see that full screen. All right.
That looks good.
Well, thank you for having me back. It's always a pleasure to come speak on the Astro Imaging Channel. And tonight we're going to do something maybe a little bit less technical than I often do. Earlier this year, I took a tour through some of the biggest astronomical facilities in the world down in Chile with three of my friends. And I thought it might be a lot of fun to share this on the Astro Imaging Channel because we got to see a lot of things that most people don't get to see. It's not easy to get into some of these things. So I thought we'd have some fun tonight. And we'll show you what some of this stuff is, some of the stuff that we got to see, and talk about what it does and what it's for. And here's who went with me. Three of my friends. I think a lot of you know Adam Block. Adam is a very well-known imager. He and I have become pretty good friends here in Tucson, working on his scope. His telescope is down in Chile and literally right next to my telescope down in Chile. I'm going to jump over to Mark McComiskey. Mark has the same telescope I have. He's in a different building, but he also has a telescope in Chile. And the other fellow we went with is Don Pettit, who is an ISS astronaut. Now, it turns out Don and I went to the University of Arizona, and we both took classes from the same professors in optics. Don majored in, I believe it was chemistry, but he had a minor, I believe, in optics. He took a lot of optics classes. And so it turned out he and I were actually in the program kind of a little bit of overlap, and we've gotten to know each other over the last few years. And when I last talked to him about my telescopes, he said, "Gosh, that sounds really cool. The next time you go down to Chile, let me know, because I'd like to go." And a lot of people say that and don't really mean it. So Mark and Adam and I were talking about going down to service our telescopes, and I called up Don and I said, "Hey, we're talking about going down there. Do you want to go?" He said, "Heck yeah, I want to go. That sounds really fun." So we were able to set up this trip to go visit some really amazing places, and it worked out really well. And Don invited us at the start of this trip to meet in Houston, where it turns out when you fly down to South America to Chile, to Santiago, you fly through Houston. So this was really easy. He said, "Why don't you come a day early, and I'll give you a tour of this Johnson Space Flight Center." And just so you know, Don is a veteran of 4 missions aboard the International Space Station. And 1 mission on the space shuttle. At age 70, he's NASA's oldest active astronaut. He's accumulated 590 days in space. In fact, I think he turned 70 on his last mission, the end of last year. And this is where we met, in the hotel in Houston. And he took us over. We stayed really close to Johnson Space Flight Center. He took us over to the Space Flight Center. We went to Building 9 first, which is the Space Vehicle Mock-up Facility. And this building is huge. It's full of hardware of every kind. This picture that I got, it doesn't really do justice to the size of this building. It's just full of space hardware. And it's got everything ranging from mock-ups to trainers. Now, mock-ups look kind of like the real thing. They're made to really look like the real thing. Trainers are not so much made to look like the real thing, but they have buttons and switches, and they're configured like the real thing so that you can train for being in space. This was an example. They had an airlock trainer there that Don said they used. In fact, he mentioned they had an airlock. I said, did you ever use it? He said, yeah, we had a problem with the airlocks one time. So they train using this stuff for problems they might have aboard the ISS. And this was a module trainer that's shown on the bottom. And this was kind of interesting. You know, you go through this with Don. Everybody knows Don there, and it's he said, I want to show you the inside of the ISS trainer here. But they had a Japanese crew who was showing up, and Don sweet talked the lady who was kind of in control of the keys and letting us in for 5 minutes before the other the training crew came up. And so Don showed us this, and it was really interesting. I think it was Mark asked him, you know, is this what it looks like on orbit? And Don just kind of laughed and said, oh, no way. He said, you know, one of the things they didn't really plan out very well on the space station were where cables go. And he said, there are lots of power cables running through everything. He said, there are cables everywhere. And he said, the second thing is, it's a little bit like a submarine. You have all these people living on the station, and they bring up supplies. And he said, you've got to store food and supplies and stuff that people need for their stay on the station. And he said they typically have those packaged up and bungeed in nets to almost all the surfaces. And he said, so you're not really walking around on things. He said, it doesn't get in your way, but he said, it doesn't really look like this in space. But all the buttons and all the things that they can do on the ISS are reproduced here so that they can train. We got to see the Soyuz capsule, which, I mean, they have one there for training. And this is a real capsule. And I was shocked at how small this thing is. This is what Don has gone into space in every time except for his space shuttle ride. So he goes to Star City and is launched on top of a Russian rocket in this thing. It looks to me a little bit like a bathysphere. You know, it's really thick walled. It's this very tiny thing. It has on top of it here on the left, you can see something attached. That's kind of a supply capsule that they take up. And Don said if you need privacy for anything, he says you can go up into that thing. He says it's usually packed with stuff, but they usually leave some room up in there. So if you need to get away from everybody for one reason or another, you can kind of float up in through there. This is a picture of Don in his spacesuit, his working suit. And while he was in Star City getting ready for his last flight, he was kind enough to send me some pictures, which I thought I'd share. And these are pictures of him being fitted for the seat in the Soyuz. And it's a little bit like a ski boat. They pour in this goo that hardens around you that forms the seat. So you have a custom seat. And you'll notice on the left side, you have Don doing a pull-up to get into this little molding chair. And, you know, it kind of relates to the fact that Don has to stay in really good shape to be an astronaut. And in fact, he told us that every day when he goes to work, he basically goes to the gym and he works out for a couple hours with a trainer. And Don is in really good shape. And I really like that about him. I mean, he works out all the time. And he said, when you go to space, you actually come back in better condition than when you left the Earth, because they're very concerned about bone loss and that sort of thing. So and cardiac function and other things. So he says they have you working out quite a bit when you're in space. And I won't say the exact number of hours, but I want to recall it was, you know, on the order of 3-4 hours a day you're working out. This is more of a close-up of that capsule. And what he told me at the time, he said, you have to be strapped in this position for 3 to 4 hours at a time for training and simulations. And for his last launch, he was strapped in there for 12 hours. And his comment was, Soyuz is not for the timid. And I have to say, when I stood there looking at this, I don't have claustrophobia at all, but I thought, boy, being strapped in this little tiny capsule for 12 hours would be challenging, for sure. It would definitely be challenging. But so it was really interesting to see the size of this thing. And of course, they had pictures of the ISS all over the place, and Don kind of gave us a tour of all the modules and kind of, you know, the science modules and all the stuff in the station. That it's really interesting. I mean, he can tell you all about it in all kinds of detail. We got to see the Artemis capsule. This happened to be the emergency egress trainer that they had at the National Buoyancy Lab. We saw another one, which is the picture below, where we could look inside. It's a lot more spacious than Soyuz, but there's 4 people that go in this thing. There are windows you can look out. It does look a lot more spacious, and you know, you do have to think about it in terms of, you know, being weightless. But you know, the crew is in there for quite a while. You know, that the recent mission, you know, it's 4 people living in pretty close quarters in this capsule, so it's pretty tight. Then we went over to the National Buoyancy Lab, which was really fascinating. This is it's the world's largest indoor pool. It's 202 feet by 102 feet, 6.2 million gallons, and it's 40 feet deep. And it's full of space hardware. There's a simulator for the ISS. At the far end, there's an underwater simulated lunar base there. And they've engineered special sand so that the astronauts can walk around in sand that doesn't get kicked up by the water. And so they can practice working on things that they need to work on in space. Excuse me. Don said that he explained that, you know, being in the water isn't quite the same as being in space, obviously. He said that your center of buoyancy isn't quite at the center of gravity. So he said you kind of move a little bit differently. But he did say something very interesting that I wanted to tell you, that the spacesuit, when you're in space, is pressurized. And so when you're moving in the spacesuit, it's actually really hard to move because the spacesuit kind of wants to straighten out because of the pressure. So he said, you know, when you come in after, you know, a long spacewalk, he said, you're absolutely exhausted. And he said, operating underwater, you know, because that was one of my questions, is doesn't the, you know, the viscosity of the water interfere with the realism of the whole thing? And he said, not so much. He said, because of the difficulty of moving the spacesuit, the water, being in the water isn't as distracting as you might think it would be. So the other thing is they have a lot of safety people there. While we were there, there was a crew that had I took this picture just after one of the crew, 2 women had come out. They had been training. And we were too far away to get a good picture of them. So I put in a picture of Don that he had sent me coming out of the water after one of his training sessions. And kind of a fun thing, when you pull up to the NBL, they have all these great signs you won't see anyplace else, you know, suited astronaut parking. It's really great. We also got to go visit the Mission Control Center for Artemis. Now, this was back in January before they launched, and they were hot and heavy getting ready for the launch, which at the time had been scheduled for February. We got to meet a couple of the backup crew, and this was Mark is Canadian, and so he was super excited to meet, and we all were, to meet Canadian members of the backup crew for Artemis. And you know, it was really fun getting a tour from Don because everybody there knows him. Don is a very outgoing guy and a lot of fun. And in fact, one of the astronauts there said to me, he said, you know, if I ever go to Mars, I really, Don's the guy I want on our mission. And I said, well, why is that? And he said, well, if the toilet ever breaks, he's the one guy I'm pretty confident will get it fixed because Don is a very mechanically minded guy. And in fact, after we had our tour, Don was very kind and invited us over to his house. And he has just probably the best man cave I've ever seen at his house. And he's got milling machines and lathes and all kinds of equipment. He makes his own wine and beer, and he has he makes telescopes there. You can see what looks like a part of a celestron mount, or I'm sorry, a mount for a I forget the name of it, but a little telescope mount there that he machined. And so it was a lot of fun looking at the stuff that he does. He also has a kiln, so he makes his own pottery. And there are a couple of interesting things about this picture. First of all, he has an HP 35 there. And an HP 35 was one of the very first, it was the very first HP calculator that came out about the time he and I were undergraduates back at the University of Arizona. And I was shocked to see it. And my old HP 45 died years ago. His still works, and he still uses it all the time. Those things, I think, cost $400 when they first came out. And then he makes his own ceramics. And these little things sitting here are space cups. And Don gives a great talk about this. And I'll give you a reference to a talk where he talks about this. But these cups were invented kind of because he wanted to drink coffee in space. And he wanted to smell the coffee. And he didn't like drinking it out of a plastic bag. And he started thinking about how could I keep liquid in a cup without it coming out. And so he started thinking about surface tension, and he was able to design these cups so that they would hold liquid. And he was able to, excuse me, just a minute. There we go. He was able to design these things, and he eventually got a patent on them. In fact, these were the very first patent for something invented in space. And he makes these for the ISS. Some professor got a hold of this whole idea and calculated the optimum angles. And Don makes these. He doesn't sell them or anything. He makes them just for NASA. And this was his latest batch. Obviously, one of them went bad, but he makes these things. Oh, he also won an award from the Museum of Modern Art for the design of these. He's a super fun guy and very proud of his old truck. I love this about Don. He has moss growing on it. He's hand painted this thing. He was pointing out the moss on it. And one of the things I do want to point out is Adam and Mark and I had an opportunity to go over to the Johnson Space Flight Center Public Museum, and before our flight left, because the flights always leave in the evening. And I have to say, this is an outstanding museum. And I think if you're ever in Houston and you have time, and you should definitely go and check this museum out. They have a full-on moon rocket sitting there that is just, this is a picture of Mark standing in front of it, but you cannot appreciate how big it is until you see it and you stand next to it. This rocket is just so big, it's just hard to even put your head around how big it is. And it's just an amazing museum. They have a shuttle mock-up. They have the old 747 that used to fly the shuttles around. That night we headed off to Chile, and just to give you some idea of where we're going down to Santiago, which is about as far below the equator as Houston is above the equator. It's about a 9-hour flight to get down there. As you fly into Santiago, you start to see the Andes there. And I fly around Colorado all the time, and I'm used to seeing 14,000 foot peaks. But when you look out at these mountains, you have to remind yourself, some of these mountains, I think Aconcagua goes up to 26,000 feet. 18,000 foot mountains are garden variety in this mountain range. So these are big mountains out there. And it's really impressive to see them on a clear day. And just to give you an idea what it takes, the first place we were going to go was the ELT, the Extremely Large Telescope. You fly into Santiago, and then you've got to get yourself up to a place called Antofagasta. And Antofagasta requires 2 more flights. So this was a pretty long day. It was another 2-hour flight after that 9-hour flight to get up to Antofagasta. And then from Antofagasta, you've got to drive down to Paranal and the ELT to be able to get to where those telescopes are located. And so in Antofagasta that night, we met up with Vincent Sook and Andres Jordan. And these are the 2 owners of Obstech. And I love Vincent because he's got a PhD in optics, and he's a professor, and he's an optics guy, and he's a great guy. I consider both these guys to be good friends. And Andreas is an astronomer. He trained in the US, I think it was at Rutgers. He's published maybe around 200 papers or so. He's the real deal. They helped a lot to put this trip together. And they knew people who got us in. And there were numerous times when Don and Adam and Mark would look at me and say, "How did you arrange this?" And I said to Don, I said, "Well, I threw your name around a lot," and that worked. But it was really Vincent and Andres who really, really helped to put this whole thing together. And so our first visit was to the Extremely Large Telescope. And this is a 39-meter aperture telescope. It's going to cost somewhere around about $1.7 billion US. It's an F-17.75 system with a 10-minute field of view with a 5 milliarc-second resolution. And this may end up being the largest telescope that ever gets built. It is just gargantuan. 39 meters for those of you who are metrically challenged. That's, you know, about 130 feet is the diameter of the primary mirror. So this is a really, really big telescope. Its mission is searching for life in the universe, direct imaging of exoplanets, getting the spectra of the atmosphere of exoplanets and looking for organic molecules, and then looking for protoplanets. Also kind of get thrown in there black hole research, stellar life cycle research, search for dark matter and galactic evolution. And those are all really valid reasons for building this telescope. But I think the real key reason that they're putting that much money into this big telescope and really sticking their necks out with this huge jump in technology is really the search for life in the universe. It's to try to answer mankind's greatest question, you know, are we alone? And that's really really what it's aimed at.
Hey,
Don?
John.
Yeah.
Adam and Don have both now joined us.
Oh, good. I'm glad.
Hi. I finally figured out how to get on. Apparently, you can't do Google Meet from an iPhone.
Oh, okay, Don. Well, I'm glad you made it here. That's excellent. We're not that far along, but we'll come back to you in just a short while here, and we'll have you give your impressions, and along with Adam. Yeah, in fact, Don, I was just about to say, well, we were there. I remember you said to me, gosh, this is so cheap. And I remember saying, 1.7 billion isn't that cheap. And you said, compared to the cost of a moon mission, this is really cheap. So, you know, it's sort of a difference in scale for the cost of these big telescopes. And of course, as an optics guy, I love the optics of this whole thing. So we have to just spend a minute and talk about what is this telescope all about. The primary mirror, M1, as we know, is 39 meters in diameter. It's made up of nearly 800 hexagonal segments. This is an active mirror. So in other words, they can adjust all of these segments with respect to each other to form one continuous phased optical surface. Light from that surface bounces back up to a secondary mirror that's 4.2 meters in diameter. It's a monolithic mirror. That's the diameter of the main mirror at Kitt Peak, at their largest telescope. That light reflects back down to a tertiary mirror that's 3.8 meters, almost as big, where it comes back up to a fold mirror and through another Naismith focus, fold mirror, out to the f17.5 focus, where the science instruments sit on either side of the azimuth bearings. So this whole thing, if you think about this whole thing has to be made. You know, all of this is an aspheric mirror. All those segments have different optical prescriptions. So this is a massive undertaking to build all of these mirrors and to get them to all phase up. And you know, on a scale of 1 to 10 in terms of difficulty of making this telescope work, this is an 11. This is going to be a difficult project. We drove up to the mountain. We got a briefing. This is a big construction site, and so we got a briefing before we went in. And these guys were super nice to us. I'm very grateful that they not only accommodated us, but they were just super nice and welcoming. We were each issued you know, hard hats and vests and steel-toed shoes before we went in and given a safety briefing. We got our first views of the dome, and this dome is like the size of a stadium. I mean, it is hard to kind of process when you see this, how big this thing really is. It's just gargantuan, and we were really excited to see this thing. And these cranes look like normal cranes, but these are the biggest cranes you've ever seen in your life. This is just enormous. And as you walk in, they put a time capsule there from 2017 when they started this project. And I said this was a project by ESO. Well, these are the flags of all the countries that are involved. And I'm sorry to say I don't know everybody's flag, but you know, it's lots of European countries. And I really take my hat off to ESO for you know, supporting this kind of level of engineering and science. This is just super impressive that they've committed to this. And it is a really world-class project. I can't tell you how impressed I was. And we'll see more of that. And when you walk in and see this thing, it's overwhelming. You have to use the widest angle you have, and even then, almost do a panorama shot to kind of take in how big this thing is. It's a giant steel truss structure. They had just installed the secondary mirror support. Remember, that's an upside down 4.2 meter concave mirror up there. None of the optics are installed at the time we were there. And you can see lots of scaffolding and lots of construction stuff. I mean, while we were in there, there was lots of construction noise. They're welding. There's, lights everywhere, workers running around. Really just incredible. This gives you a little bit better idea of the scale. This is not wide angle. This is like walking underneath it. It's like walking under a bridge. And, M1 goes way above us there where I put the arrow. It's way up there. And we walked around on this platform underneath the system. And as I walked around there, I noticed this safety tape there, and there was a hole in this little bridge we were on. And I kind of thought, what's that? And I looked down, and there was a hole about 1 meter by 1 meter, and it was like a 20-meter drop to the floor down below. I don't know exactly how far it was, but it was enough that you probably wouldn't survive the fall. And they didn't have much safety notification. I kind of said to everybody, be careful, there's a big hole here. And Don at one point looked at me and said, NASA would never let you walk around in a place like this. There were definitely hazardous areas there, but it was just overwhelming. This view of this telescope was just incredible. This was kind of a side view showing the enormous azimuth bearings that the telescope rides on. And then there's the azimuth platform, and there's one on either side for each of the bearings. The telescope obviously here is pointed straight up. Again, it's a little hard to take all this in while it's under construction, but we could see it, and they're committed to it. By the way, they're making all the optics in France. I believe it's being done at Riosc in France. So they have a big contract to make all these components. And I'm proud to say they have the interferometers that we used to sell at our 4D interferometry, our phase cams, and they use that for this stuff. They took us down underneath the telescope, and this was fascinating. They have all these seismic dampers and springs. So that whole telescope sits on these giant springs and damper systems because Chile sits in an earthquake zone. And I've felt numerous tremors when I've been down there. So you can see some of these, and these are all just gigantic. So I was really impressed by the level of engineering behind this whole building. I mean, it's really first class. It was actually very clean down there. I was pretty surprised. And at the end of the day, we took off and we headed over to Paranal and the VLT, the very large telescope. And Vincent had actually worked at the VLT. He was super excited. I didn't know that much about it, but I was really glad we went there. So this is kind of what the entrance looks like to Paranal. You can't just walk in here. You don't drive out there and hope for a tour. There's gates and everything. So we had this all set up, and this was just fantastic. And they told us we could stay in the astronomers' quarters. And of course, I thought this is just going to be like some concrete building with a bunk bed. But no, it was a full-on, I'd call it 4-star hotel. And it was just spectacular. And it's underground. In fact, from above, here's what you see. You see this little dome. It's built in the side of a hill, so it's not completely underground. But when you first walk up to it, there's no real building there. It's just kind of a mound in the ground where the hotel is. And during the day, they have this thing is a skylight. And I'm going to go back. And in the upper left, you can see that pillowy material there. That is actually a light block that they have. To prevent the light from going out into the sky to protect the telescopes. And they have a pool, they have ping pong tables. It's just fantastic. And they have, these great sort of public areas where you can sit and talk ideas with other astronomers or engineers. They gave us these little rooms, and, most of the people working there are working all night long. So these, there are no windows. You can close the door and have it perfectly dark during the day so you can sleep. And I just have to add, this just cracked me up. This hotel is the same building they used in the Quantum of Solace in the James Bond movie. So if you watch that movie, the good guys and the bad guys are all running around here. And this is a frame from that movie where they blew up this hotel. I kind of watched part of the movie. I didn't, it wasn't my thing, but it was kind of fun to see that. I don't know how they even found out about this, but how somehow Hollywood found out about this and they thought it was the perfect villain's liar. Up on the mountain, they have 4 8.2 meter telescopes, and they've named them all after the sun, moon, Southern Cross, and the morning star, or Venus, in the Mapuche language, which is a sort of a central Chilean language. And we didn't get to go in to see those telescopes. They're 8.2 meter telescopes. And then it's surrounded by a big kind of area here. And this is where we're all standing. Adam was kind enough to take this picture. Mark and Don and I are out there, and there's railroad tracks, and there's these domes that contain smaller telescopes. And we'll come back to that in a minute. This is one of the 8.2 meter VLT domes. And of course, they're all fixed because they're huge. And at night, they use lasers to create artificial guide stars. And they're not really guide stars. They're stars that are used for atmospheric correction. And they use 420 watt lasers. And these are tuned so that they excite sodium atoms at about 90 kilometers altitude. And that forms an artificial star that they can use for the active optics to remove the effects of the atmosphere. So these telescopes, over a fairly small field of view, are basically diffraction limited. So these have very, very high resolution, much beyond what you could ever get from Hubble or even JWST, but the field is much smaller. But when we walked out and saw these lasers turned on, it was just incredible to look at this. And this is a photo that Mark took with his iPhone, and it just really looked like Star Wars. It was just a breathtaking sight into this pitch black sky, these lasers beaming off. And Don and Adam went out and got a great shot of the lasers at night. And this was a really great shot. I love this. Don came very well equipped for this sort of thing with some cameras. And he got the large and the small Magellanic Clouds, the coal sack with the Milky Way and the laser, but he also got the air glow. And at this time, the solar activity was extremely high. So we had a lot of air glow. And Mark and I both commented, Mark and I had been down there a number of times, that the sky was not quite as dark as we remembered it. And Adam explained that that's mainly because of the air glow and the solar activity. And so it was most noticeable over at Obstech, but here the sky was extremely dark. This picture doesn't really kind of give you an impression of how dark it is. You can't see your hand in front of your face. It's really, really dark down there. And by the way, these lights, they have the road to the mountain lit up with little low intensity lights that are along the side of the road, so you don't drive off the road in the dark. So you can drive up there with either low beams, either parking lights, or just, you could almost drive up there with no lights, but I don't think anybody does that. These are the 1.8 meter scopes of the Very Large Telescope Interferometer, the VLTI. And these are on these tracks, so they can move them around to change the baseline. And again, we didn't see the telescopes themselves, but we saw something that I thought was even more interesting. And just to explain, when I talk about interferometry, what are we talking about? These are white light interferometers, and this is like a double slit interferometer using starlight. So two telescopes act like, like each a slit, and light from the star is then combined through a delay line. And you have to do that because the light is not monochromatic. It doesn't have a long coherence length. So you have to match the paths between the two telescopes. So that delay, b sine theta there, changes as the telescopes track. So not only do you have to match the paths to less than one wavelength of light, but you have to track that optical path difference while the telescopes track across the sky. So this is what I consider to be kind of a mind-blowingly hard problem. It's been solved for many years, but there are not that many interferometer systems around, stellar interferometer systems around the world. I think there's, I should need to be careful here, but I want to say it's maybe 4 or 5 systems around the world. And that path matching thing is pretty interesting. And they took us down to the beamlines, and we got to see the optical beamlines. And these are 150 meters long. These are just enormous. And this is what they track. This is looking in one direction. And if we turn around and look in the other direction, there it is in the other direction. These run on these optical rails. And this was just extremely impressive. And you have to understand that for interferometry, you also have to have very stable atmosphere. It's a little bit like seeing for when we're imaging, except it's even more sensitive. And so nobody can go in here when the thing is actually running. And I asked them, I said, how much of a problem is air turbulence? And they said, oh, we don't have any trouble. They kind of waved it off. But I was extremely impressed by this. And the light, of course, passes back and forth through each arm. It's double pass in each arm. And then it gets fed into another area. But first, let me just tell you what it is they're looking at. This comes from something in optics we call the Van Zernike theorem. And what it is that the pattern that we get, the interference pattern, is modulated by the distribution of the irradiance pattern in the source. And this is dealing with something called spatial coherence. And if we can just look at that envelope of the interference pattern and inverse Fourier transform it, we get the distribution of the source. So this is a way to go backwards and to look at very, very tiny objects, much smaller than we could even look at with the ELT. So we can generate very large baselines beyond even the 29 meters of the ELT, and look at very, very tiny things to measure stellar diameters and look at double stars and that sort of thing. And this all has to be stable to within a fraction of a wavelength of light. This is one of those things that you see in a textbook and you think, oh yeah, okay, I understand how that works. But if you've ever done interferometry, particularly white light interferometry, and you will understand that this is one of the hardest things. I mean, this is incredibly hard. And I just was dumbfounded by this whole thing. And all of this requires a lot of optics. And so they brought us into the beamline rooms where all this stuff comes together. And this is where they launch the lasers. This is where they do the image correction. This is where they do the interferometry. And we walked around, and these are all big vibration isolation tables, loaded with optical components. I mean, I walked around in there, and I've been in a lot of optics labs, and I've seen some really complicated stuff, but I was just absolutely dumbfounded by this stuff. I thought I could spend 2 weeks here maybe and maybe half understand all of this stuff. I was really impressed by this. Just the difficulty of lining this all up. This was where the lasers are generated. They had the high power lasers in here. And again, I can't tell you what the beam paths were, but I was extremely impressed by the skill of everyone who had worked on this to line all of this up properly. And this is really some impressive optics. And from there, Vincent and Mark and I went up to the control room, and Adam and Don had some fun out under the sky taking pictures. We went up and met some guys, some folks up in the control room, and this is for the VLTI control area. And this guy, Julian Dravon, was there, and he was very generous with his time. You have to understand, to get time on these big telescopes is a big deal. So we didn't want to take a lot of their time. You know, this is their time to do their work. And Julian was a fairly new astronomer there, is my understanding. And he had just published his first paper, and he gave me a copy of it, and I'll show you something interesting. But they were working on getting some data there. We got to look over their shoulder. I wish I'd taken a picture of the interference fringes, but they were taking data. And it was really fun to, I think, you know, as I started asking questions, and Vincent did too, that Julian realized we weren't just anybody. We kind of had an idea of what they were doing and how it worked. And he got a lot more interested in talking to us. And in fact, I just saw that at the SPIE Telescopes and Instrumentation meeting that's happening in Copenhagen next month. He's there, and he's actually got a challenge going. He's supplied data, and he's asked other groups to process it to see who can process the best images out of their interferometer data. This is the kind of images that he produced. This is at 4.033 microns. This is mid-IR. This is not visible. Still very difficult to do. But he produced a direct image of a mass transfer between a dwarf star and another star that are in close orbit. And he was able to image the mass exchange. And it's a very impressive paper. And I was super impressed by the images and what they were able to do with this data. We turned around and kind of ran into these two guys, and they were working on one of the big telescopes, and they were commissioning a new imaging spectrometer there, which I was really fascinated by. And they were kind of busy. And again, they don't have much time on these telescopes, so they're focused on making things work. But once I asked them a couple questions, they got kind of excited about explaining things to me because it's their baby and they wanted to tell me all about it. But I tried to kind of minimize my questions, so we only took up 5-10 minutes of their time, no more than 10 minutes. But they have a fiber bundle that had maybe 1,000 fiber ends, and they had spectroscopes attached to each one of those, so they could look at the spectra of multiple stars or objects in a field. It was pretty cool. And from there, we went on to the Rubin and the telescope and the LSST. And for those of you who might not know what LSST means, it's the Large Synoptic Survey Telescope. And that's how I know that telescope from the time it was being built until the observatory was commissioned and named for Vera C. Rubin, who, by the way, was the discoverer of dark matter. And you take a plane from Antofagasta down to La Serena and then a van ride. So it's about an hour and 20-minute plane ride and then another 2-hour ride. And Vincent very nicely arranged a van for us to pick us up. And we were able to ride out to the observatory. And we passed lots of observatories along the way. I didn't even take pictures of half of them. There are telescopes all over this region. It's really impressive. We arrived at Rubin, and I'm sure you've seen this picture. This is kind of the press picture. I took it, but it's the same one that they released to the press, and that's what the observatory looks like. It's very modern. I should have looked it up. I forgot the altitude of this. It's pretty high up. I want to say near 10,000 feet, 9,000 or so feet. And this building, kind of attached to the observatory dome, contains all kinds of workshops and areas to maintain the telescope. And one thing we don't often think about is these big telescopes, occasionally the mirrors have to be recoded. And so they have to have their own recoding chambers and everything. You can't, this isn't something you pull out of there and just mail it off to have it coded. They have to have a means to do that. So this is their means. This is their workshop area. And it's really fascinating walking through there. They had all kinds of interesting stuff in there, along with great big cranes to move everything. And then we got to walk into the telescope and see what it looked like. And gosh, I mean, it's huge. It's a very stubby telescope. One of the first things that you notice with this telescope is the big flat panel. There aren't very many big telescopes when you go in the dome where you see a flat panel. There are some, but not a lot of them. And we'll see in a minute why that's so necessary. But it's a very impressive telescope. They were very gracious about letting us kind of crawl up on the stairs and look around the telescope. I didn't think of asking them to move the telescope. I think they might have done it for us if we wanted to kind of look down into it a little bit more, but I didn't think of asking them that. I think we were all kind of starstruck looking at this telescope and crawling around it. We didn't think of that, but it was just amazing to see this thing. And of course, I have to tell you a little bit about how it works. It's a big monolithic mirror that has two surfaces in it for the primary, and it's 8.4 meters in diameter. And M1 is f1.18, and it focuses the light up to M2, which is a 3.4 meter telescope. It operates at f1 and sends light down to M3, which is polished into the same piece of glass as M1. And that is then focused up onto what turns out to be the largest precision lens ever made. It's 1.55 meters in diameter. And it's ultimately focused through another lens, filters, and a third lens onto the sensor. The sensor is 0.64 meters in diameter, which is roughly a little bit bigger than 24 inches, 25 inches or so. And that whole lens assembly is about 1.03 meters deep. And the thing I want to emphasize here, this thing is not built to be diffraction limited. This is a big, wide field telescope. It's made for field, and it's optimized originally for about 0.7 or 0.6 arc seconds. And you can see the spot diagrams here show a square of 0.6 arc seconds. So this has kind of, similar resolution or similar spot size to what my ASA telescope has. Similar. It's a little bit better, but it's, this isn't, a diffraction limited telescope. It's really built for wide field, and it's optimized for the local seeing, which might get as good as 0.5 arc seconds out there. I think I saw the design spec, and the design spec was for 0.7 arc seconds. But the camera, the sensor, is 3.2 gigapixels. They're 10 microns. They're sampled at 0.2 arc seconds per pixel, which is pretty close to what my telescope is. These were images that I took way back in 2017 in the Large Mirror Lab here at the University of Arizona, where that mirror was made. This was shortly before they shipped it. This was, you can see a guy sitting on M3. He was, I don't know what he was doing. He was cleaning something, or I don't know what he was doing. But this is the stress lab polisher where they made it. And I was in that facility many, many times. We sold lots of interferometers in there, and we came over and helped them set them up and stuff like that. So our phase cam interferometers tested all this, which, you know, I'm pretty proud of. And it really enabled a lot of these big telescopes. And they used them for the VLT mirrors and for JWST, and all these big telescopes used our technology. This was looking up at the M2. We could actually see it up there. Lots of light baffling around there. I asked them how long it took to align the telescope. And they said, oh gosh, you know, the mechanical engineers did a great job, and we had it aligned and getting pretty good images within 3 days, which was shocking. I mean, for the complexity of this thing, they really had it pretty well dialed in. So when they first put it together. This is the largest lens ever made. We could see it there. And it is big. And we couldn't see the sensor, but the sensor sits in this tube, which I pulled this picture off the internet. But you know, the sensor's in the back of this. And remember, if they take a long enough exposure, they've got to rotate this at sidereal rate. And I never asked them how they do that. They may, if the exposure with their short exposures, they may not have to rotate it. I didn't do that calculation. I didn't ask them about that, but I'm sure they built it in so it could be rotated. This was in the control room. It's again, this telescope, we were there maybe, what, 8 months or so after they first started getting images. This guy in the orange vest there he told me it's from like Tennessee, or I forget exactly where he was from, but or Alabama or something. But he had a degree in physics, and I think he was living his dream there, helping to get the telescope running. And so they kind of showed us what was going on the screens. So it was kind of fun to see the control room. This is why you need a flat panel. That big sensor is really made up of lots and lots of little sensors. It's a CCD camera. They've got lots of PRNU, you know, fixed pattern noise all over that whole sensor. So they really need a flat panel to calibrate all that stuff out. And just to make all you guys who have troubles with cables feel better, you know, cables are always a problem. And I really appreciated the tour underneath the telescope here, where we could see what they did with the cables. They just created big loops. So when the telescope rotates, those loops just kind of move around in such a way that it doesn't bind, and the telescope can move without anything getting hung up. And they just have a great big room there with these great big cables hanging down. I thought that was really fascinating. They have a server center there to handle the data load. They're producing, you know, terabytes. I forget, it'll say here in a minute, 26 terabytes or so every night. It's a lot of data. They opened up this little door so we could look underneath the mirror, which was kind of fun. That's what it looks like under the mirror. And these are all actuators that help equalize the load on the mirror so that it doesn't distort. These mirrors, by the way, weigh about 20 tons. They're pretty rigid, but you know, when you're talking about nanometers, they can flex under gravity load. So they are very careful to support the mirror carefully to maintain the figure. The science mission here is to image the entire visible night every 3 nights. They're using either 30-second or 2 15-second exposures. And I asked them while they were there, and nobody seemed to know what they were using. I was kind of surprised. I thought this is my big chance to find out, but they didn't know. They go to about 27th magnitude in those short exposures in 30 seconds total. They're generating about 20 terabytes every night. And they're looking mostly for point sources with this telescope. So they're looking for near-Earth objects. They're looking for, you know, dinosaur killers, which, you know, now won't be dinosaurs, it'll be us. And they're looking for supernova. And supernova are extremely important for understanding the size of the universe. And so that relates to the searching for dark matter. So supernovas are standard candles, and they discover them all the time with this telescope. So it's helping to aid in properly scaling the universe. And finally, I have to say, this telescope's going to make it hard for amateurs to discover new objects. This thing is constantly imaging the sky. I was amused. They have a dim seeing monitor out there. This is just an amateur telescope sitting out there. It was maybe a 10 or 12-inch telescope on an amateur mount that just sits out there to monitor seeing. They had a really cool little guest book. This is all embossed and everything. So we got to sign their guest book, which is kind of fun. And then we drove over to Obstech, and you drive kind of through some Chilean wine country there. It's very mountainous. It's supposed to take 3 hours and 33 minutes. We got stuck on the road where they were repaving it. It wouldn't dry. We had to sit there for a couple of hours out in the hot sun waiting for the road to dry so we could drive on it. They're only about 7 miles apart. I can see Rubin from Obstech from my telescope. It's visible on the next ridge over, but it's a long trip between the two. And here's what Obstech kind of looks like from the air. This is a kind of a simulated view of it, or maybe it's real. Vincent put this up on their website, and it's 3D. You can kind of move it around. It's really cool. They've got around 140 private and professional telescopes there. And the new Mothra telescope arrays are there. And so we're going to take a look at that. And it's really interesting. In general, the scopes range in size from 60 millimeters up to 1.5 meters. They just had a new 1.5 meter installed. Here it is. We saw it sitting at the front door. It's now installed and up and running. Mike Selby owns this and operates it. It's an ASA telescope, and it's working beautifully. The main building entrance is right there behind that telescope. It's not very imposing, but that's it. You walk in there, and they have the whole control system there on the left, and they monitor weather and power and all kinds of stuff there. And they can get into your telescope there if you need to. You turn around and you're in the kitchen, so it's kind of an intimate experience there, but very comfortable and pretty nice. For those of you who haven't seen my other talks about Obstech, here's just a view of this happens to be the small telescope building. They just have one of those. The rest are much bigger telescopes, but of every kind of telescope. I'd say the median-sized telescope there is probably 24 inches. Don was nice enough to walk around, took pictures of all of us working on our scopes there. And we all had a lot of fun there. We were there for about a week, and we had a lot of fun. Don took lots of pictures, and we got things tuned up. This is Don's view with Vincent and Andres of the Mothra, and I'll tell you more about that in just a second. And Don helped Adam work on his scope, and they had had a lot of fun working on that, getting it balanced and some other things that needed to be done. So that it was just a great opportunity to kind of work on things. These are what the Mothra telescopes look like. Each one of these has 36 individual telescopes. This is imaging in parallel, massively parallel imaging. The total array has 1,140 Canon lenses. They're 400 millimeter f2.8 telephoto lenses, and these have extremely high transmission coatings on them. They have tunable ultra narrowband interference filters. It's optically the equivalent of a 4.8 meter f.08 refractor with a 2 by 3 degree field of view. And the cool thing about this, I kind of uncovered while I was looking at this, is that this was funded by a private guy, Alex Gurko, who's the CEO and founder of XTX Markets, invested $80 million of his own money to fund this for 5 years. And, I got to say a thank you to him. I think this is just really cool that he did this. And so this is, this isn't government or science foundation money or anything. This is private funding to a research group. And, I love this. I think it's pretty cool. Their science goals are really to look at faint extended objects, to map out the circumgalactic medium in the nearby universe and reveal the brighter pockets of the cosmic web, which are large collapsed structures in the universe. Excuse me. And it's a fascinating effort. They were experimenting here with ways on the left of ways of keeping dust out of the system. They had just had saran wrap over these. I thought that was a terrible idea. I said they should just get optical windows and put over it. But Obstech, the techs at Obstech are putting things together. And the arrays are located on opposite sides of the mountain, which I thought was really interesting. There's 15 mounts on the far right side there. And there's 15 mounts on the upper kind of left side of there. And they did that to generate parallax to remove satellite trails. So I thought that was really a pretty clever idea. and I won't go through all of it, but there's a lot of interesting stuff at Obstech. It's a really interesting facility. Mothra is about 30% complete. It's scheduled for completion December of this year. And they're desperately putting all this stuff together and testing it, getting it aligned and getting it running. We spent 6 more nights there working on our scopes. And Don worked on skyscapes and imaging, and boy, we just had a ball. And I just have to mention, they've installed new guest accommodations there. The first time I went out there, it was just barely one step above car camping. And now it's really nice. It's almost hotel level. They've put in showers and heating and cooling, although we didn't have it. Adam had to suffer through no heat, I guess it was. He was freezing. Or no, it was the other way around. He was burning up. It was hot. But anyway, it's much nicer there, and they're kind of making it a little easier for those of us when we visit. And I just had to throw this in just for fun. I saw my first tarantula in Chile. He was walking on the wall just out kind of next to the kitchen, and he was just walking around. I was shocked. It's exactly the same kind. It looked exactly the same as what we have in Arizona. Totally harmless. He kind of walked around. We took lots of pictures, and he finally walked outside. So if you want more information, I'm trying to do this so I leave a little room for Adam and for Don here. If you want more information on Obstech, I did this a while back. I did a whole thing about remote imaging, a lot more detail on Obstech. Adam has a really excellent video about our trip with his impressions, and here's the address. So if you want to hunt for it on YouTube, I highly recommend it. It's really good. And then while we were there, Don gave a really fantastic talk while we were at the VLT. And Adam worked pretty hard to put together a video of this talk, and it's fantastic. And Adam did it with just using his cell phone, and he did a really admirable job with kind of being under-equipped to do it, but it really came out great. And so here's the address for that particular talk, and I highly recommend it. Don is a great speaker, and he's got lots of interesting stuff to say. And so I say to you guys, congratulations. Now you know more about some of this bleeding edge astronomical stuff in Chile. And I've kind of said my part. And I mean, I'm happy to take questions, but I wanted to invite Don and Adam, hopefully with a little bit of time here, to give their impressions of the trip, just kind of briefly. And then maybe we could all take questions, if that sounds good to you, Molly.
Yeah, absolutely. We do have a couple questions up on the chat, but yeah, if Don and Adam want to pop on here and give some input.
Yeah, and I'm going to stop sharing my screen here. Just give me 1 second here when I find it. Stop presenting. Oh, wait. That's
toward the upper right.
Yeah, there we go. Thank you.
Yeah.
Okay, good. Okay, Don, I see you there. You want to give your impressions of this whole adventure?
Yeah, this was an amazing adventure. It was the first time that I'd been to South America, let alone all the way to these remote places. And one thing I do want to say, we flew 5 different legs on Chile internal airlines, and we never had a single issue with doing all that flying around inside Chile. That was really really interesting to see. You don't want to have a phobia about flying around if you're going there.
Yeah. Yeah.
You know, we did have a question related to flying. I think it was Mark Hilton asked, no, it was Aerostar that asked, did you fly your Mustang or did you go commercial?
No, that's really not, my airplane is not a good tool for that job. It's a long ways down there. And I have flown an airplane down there with a friend of mine on a tour, but not for this kind of job. And so flying commercial down there is really the way to go, unless you're just going down there to fly. I mean, that's a whole different talk. But this was really a better job for the airlines.
Okay. And Mark Helton wanted to know, this probably for all you guys, Adam and Don and John, what again is the altitude there, and how did you acclimatize yourself?
Adam, you want to try that one?
I don't think the mountains were all that terribly tall, not that I recall. So I'm accustomed to going up and down mountains because I worked on many throughout my career. So for me, there was no acclimation. I mean, 9,000 or 10,000 feet isn't a big deal. I maybe was the ELT this tall? I don't even know which one was the tallest one.
Yeah. So
none of them really felt that tall to me. So
Obstech is around 5,500 feet-ish or so. It's not that high.
Oh, that's not much.
VLT might have been 9,000 or so.
Yeah.
And I don't recall how high ELT is. ELT might be a similar altitude. So it's not high enough that you really have any trouble. I mean, I suppose if you go running up and down hills, you might get winded, but for just walking around there, it's not a problem.
Well, in Houston, my house is at 23 feet above sea level.
Yeah. And you had no trouble walking up and down.
Yeah, well, we do a lot of training.
Yeah, well, that's right.
I mean,
pretty fit.
Excuse me.
Don, you're kind of used to higher altitudes anyway, right?
Yeah, and when we fly these NASA T-38s, it's a airplane designed in the late 50s, built in the 60s. It's a twin engine afterburner supersonic Air Force training jet, and we use this for space flight readiness training. And its compressor system for maintaining cabin altitude doesn't work very well. So when we are at high altitude, say 40,000 to 45,000 feet, the cabin pressure that we're in is like equivalent to 20,000 feet. So we have to be breathing with a face mask. We got to be breathing an oxygen supply in order to keep from passing out.
Yeah.
I was going to say that Jaime Zapata, who works the technical ends of this and is with us in the Astro Imaging channel here every Sunday, and I and a couple of other people gathered together down in the Andes a couple of weeks ago, and we were running around up at about 15,000 feet, and I was thinking, I can still do this, and it really isn't affecting me that much. And then I got back to Los Angeles, and I realized, you know what? It was affecting me that much. I was really moving a lot slower at 15,000 feet and at 12,000 feet than I had when I got back. And there was one other question from Chuck, and I've lost it here. He says that when the arc seeing, when the seeing gets down to less than 1 arc second, that all of the concrete foundation becomes rubber. And he said John Hayes would know what that was about. We couldn't figure out what he was asking.
Well, what I say all the time is anytime you're thinking about your telescope structure and how stiff it is, you got to remember that at 1 arc second, everything is made of rubber. And so you want to make sure everything is as stiff, mechanically stiff as you can. Now, it can get it. Now, these telescopes that we have down in Chile, of course, we have everything bolted to big piers and big pieces of concrete. But when you see these big telescopes, it's true, that the ELT with a resolution of 5 milliarc seconds, the mechanical stability of that system has to be extremely high. When you talk about things being made of rubber at 5 milliarc seconds, everything is made of really wobbly rubber, made of jello. You have to be really careful to do that.
That was safer than some of the meaning of that question. We couldn't figure out what it was about. So,
well, before we get too much further along with questions, I wanted to ask Adam what his impression.
That's it. The question.
Because I didn't want to pass up Adam to see, because I'm sure he had some good observations and comments as well.
Oh, just about the trip in general?
Yeah, and what we saw.
I think the first thing that I need to say is that I think the company was exceptional. I haven't been on a trip like that where I've joined, like-minded people. And then, of course, Don was the astronaut. So that in and of itself, just being with you guys, I think was quite an experience for me. And then on top of that, I mean, my impressions are there were many firsts. You guys have been there before. Don has been in space. I've never seen those stars, and I've made a career out of astronomy. So for me, when I visited Paranal, and after dinner, I knew it was going to be dark. I knew that there was going to be, and you don't get many after a certain age, there was going to be a first for me, a lifetime first, was to see the southern stars. And I remember that feeling of excitement, and I remember being able to go outside, and I was very impressed, particularly, of course, with the Magellanic Clouds. I've seen pictures of them. I've read about them in books. But once you see them viscerally for yourself, you really can add another dimension of what it means to see the whole sky. And I thought back to the guy that stepped outside and saw the supernova in 1987A. I mean, now I know what he probably saw because I know how bright a star is, and I know what the Magellanic Clouds look like now. And so for me, that was important. And then also, again, at Paranal, I had a chance, as you mentioned, to spend time with Don. While you guys were at the telescope, we were outside taking pictures. And Don is one of a very small group of people who not only have been in space, but paid attention to what it looks like outside the window. And that's what I've done from the ground. And so having an opportunity to have a conversation with Don about what it looks like, and we're both there under the Earth sky, and he can tell me what it looks like from space, that to me was an extraordinary experience, because I couldn't have that conversation with really anyone else. And so that was great.
And Adam, I have to say that I was honored to be there with you and Mark and John, because I don't get to hang around people like you. I mean, I'm hanging around all these fighter pilot types, and they want to light the afterburners, and they want to do all this kind of stuff. And it was neat being there with people who truly understood what it means to look away from our planet and be in awe of what is there.
We did have a question related to just what Adam said right now, coming in from Brody Mac 45. How do the skies in Chile compare to the skies in space? And that was directed at Don.
Well, stars all look the same in terms of their patterns, because you're only 400 kilometers closer to them, right? So that aspect doesn't change. The aspect of the moon doesn't change. Aspect of the sun doesn't change. What does change is the brightness and the colors that you can see when you look with your eyes into the night sky. And we've seen these wide field astrophotography images that are composites with hydrogen alpha and maybe a few other wavelengths, and they have all these dynamic colors that you could see. You could start to see those kind of colors with your own eye when you look at the sky from an orbiting environment. And your eyes have to be dark adapted to do that. But there is certainly more color to the night sky when you're looking at it with your own eyes, as opposed through a CCD camera or a CMOS sensor.
Thank you.
Now, I do want to point out that John showed a partied picture of my 0G coffee cups, and I'm sitting here sipping out of one of them right now. And anyway, the shape of this cup allows you to have an open container and control the fluid and sip it in a weightless environment.
So I take it, Don, that the surface tension of the water molecules holds it in the cup the way you designed that.
Yeah, the surface tension does, but it would also do that with a cup shaped like this, but the fluid would stay in the bottom of the cup and you'd never be able to get it out because you go any direction and it just sits there in the bottom of the cup. These cups have an acute angle, and that angle drives channel flow. And if this angle is less than 2 times the quantity 90 minus a wetting angle, then you'll have channel flow, and the fluid will move up and park itself right here next to this cusp. And then you could sip some of the fluid, and then more fluid will move up and replace it. So the dynamics of the fluid physics associated with this cup defines not only its shape, but it also makes it functional.
And how does it work on Earth? How does
it works fine. Now in space, you can only drink from this end, but on Earth you could drink from either end.
And I just want to add, as a way to perhaps, I'm going to take advantage of this opportunity to ask the Astro Imaging channel maybe to really point at Don's talk, because it's very good, and I don't think it gets enough attention or highlight. So I have it on my own channel, but no one watches it there. It's not really aligned with a lot of the other content that I put, but it might find a better home on the Astro Imaging channel. So there's a possible
See what we can do.
Yeah,
We would love to have you on.
it's probably a better place to post it.
Would you like to come on and give that presentation on the Astro Imaging channel, Don?
Oh, I'd be happy. I could talk for hours, not just 40 minutes like John, but I could talk for hours on what it means to fly in space and or take pictures and do things in space, and it's all good stuff. It's all good stuff.
Yeah, your
Well,
talk at NEAC was awesome.
Yeah.
Molly, do you have Don's contact information? Because I think we'd love to have him.
Yeah, absolutely. I can get that from John, or Don, you can message us after the show is over.
Yeah, in fact, Molly, I got I think you were on an email. I was frantically trying to figure out how to get on this Zoom meeting, and it turns out I can't do it from my iPhone without installing the Google Zoom app, and my NASA issued iPhone doesn't let me install new software apps, and I was trying to figure out what to do. So I finally switched to my laptop computer, and then you could just go in via the internet.
Yeah.
Well, Don, you've got Molly's information, so if you just send her a note, if you're willing to do it, I think it'd be fantastic.
Yeah, I'd love to do it.
Yes,
Are these programs typically on a Sunday evening at this time?
They are. Yes.
Oh,
Yeah, same time, 8:30 Central Time.
It's
time
funny
you're-
that every show, this is a message for all of you listening out there. Every show we ask you to volunteer, and this is as easy as it is, guys. You just tell us you want to be on the show. Boom, Molly fixes it. It works that easily, really.
Yeah.
And you don't have to be Don Pettit. It's cool to be Don Pettit, but you don't have to be.
But
you don't have
Alex,
to be an astronaut.
Yeah, but Alex, you get what you end up with if you just wantonly ask people to come and give a talk on your program.
Well, if you watch all 13, 14, 15 years of it, you'll find out that it's generally pretty good stuff. We do have a bummer now and then, but what do you think, guys? Yeah, we do pretty good.
We have a lot of great content on here, if I do say so myself.
Yeah,
We've
yeah,
been doing this, Alex and I, how long have we been doing this? 11, 12
Yeah.
years?
Yeah,
Yeah,
11,
Tom, if
11
you
years.
explore a little bit, you'll see Astro Imaging Channel has a lot of really good content. So you would join it's a good group to join to be a perfect.
It is not unusual for us to be at a big astro imaging place, big convention or something like that, and have people actually say, "I'm going to have to get this on the Astro Imaging Channel." And so that
Hey,
happens.
That's how I booked the next like 3 months of speakers was from NEAC.
Yeah, I just heard one of the astronomers that works for Rubin give a talk. I was in Phoenix last week at the Arizona Science Center, where they have a 60-meter LED dome for their planetarium, which is just spectacular. And this gal showed a number of these wide angle pictures taken from Rubin. And one of the things I noticed was the stars, the bright stars, had 4 points from the spider, but there would be a 4-point that would be red, and then slightly rotated, there would be another 4-point that would be green, and then slightly rotated, there would be another 4-point that was blue. And I was thinking about that. Why would that be? Because these were obviously pictures that had been put together, taken at different wavelengths with filters. And I'm thinking that's because it's an alt-az telescope.
That's
and
right.
when they put these images together, the
quite matched.
location of change.
Something is,
You dropped out.
it's something like that. Yeah.
I think you're exactly right, Don. I think that's exactly.
And
right.
I'm wondering, does anybody have any thoughts on that?
You're
Yes.
breaking up, Don. It's hard to catch every word.
Yeah, we're losing your signal.
Yeah.
But exactly, you described exactly what's going on. They're taking the
John,
solar
this
channels
is another.
at different times and they're not rotating the sensor. Let me just ask, do we have any other questions on the presentation? Or the trip
We've got a
before we-
lot of comments. I think people really like the show, and they did ask that we get a link to the Adam
For a donut.
story, I think, or Adam's report on Don's program.
Just
I did put it up on the last slide. It is there, but it'd be nice if you can
the
just add it to
figure on the large mirror.
Don, you're dropping in and out. I think we've lost Don.
Gosh, I hope that's a technical difficulty, not a medical one.
Oh, that's what happens when you use TDRS instead of Starlink, right?
Yeah.
Oop, he's gone altogether. Who's in charge? Linda?
Okay.
Yeah, supposedly. I think for many of us, the idea of being in the places that you guys visited is a trip of a lifetime. And so to get to live vicariously through your trip is pretty amazing and humbling to see these places where some amazing science is being done. So thank you so much for sharing that. Does anybody have any last comments before we head off for the night?
I guess I just have to-
Brody asked a question, but I'm afraid we won't be able to help much because it's about whether Don can tell him how to become an astronaut. And besides getting in really good shape, apparently, he's going for right now. Is the NASA
Well, I
apparently
just have
found
to
him-
add. I just have to add one thing to emphasize what Adam said. It was really fun to go with Adam and Don and Mark, and we just had a great time together. And it was, I think, we got to visit some really world-class places, but we also really got along really. It was just great traveling companions, and we just had a lot of fun. This was really a sort of a world-class bucket list trip, and I'm glad you gave us the opportunity to share it, because we did get to see things that are not easy to see. It was just amazing. Don kept saying to me, "How did you arrange this?" And it was really, I think, Vincent and Andreas and a little bit of Don. Tell him you have an astronaut along doesn't hurt, but you know, they really bent over backwards to help us, and I want to make sure that we acknowledge that, because they put in a lot of work to help out on this whole thing.
That's amazing, and thank you so much for sharing it. I for one really enjoyed seeing the pictures and hearing the tale. So we'll see everybody in 2 weeks for Richard Wright, and I hope you guys get some less crazy weather than we're having in Virginia right now. So take care, everybody.
Don, Adam, feel free to stick around after we end the live stream and hang out to chit chat if you would like.
Okay.
Yeah. So that's it. Molly, you can take us out.
Alrighty. Good night, everybody. Thanks for coming.
Good night.
Good night.